Hey everyone, Geek37 back with another video. And in this one, what we're going to do is we are going to derive a numerical answer for the given problem up above. Cosine squared of pi over 7 plus cosine squared of 2 pi over 7 plus cosine squared of 4 pi over 7. And that's going to lead us into some other calculations that I want to do in this video. Let's start off by writing down the ratios for that we remember from prior in this series. So the cosine of pi over 7 was b over 2a. The cosine of 2 pi over 7 was c over 2b. And the cosine of 4 pi over 7 was negative a over 2c. I'm going to change this down a bit so we can make it a little neater. So here's what will happen. We have the cosine of pi over 7 squared, and we'll plug that in. So b over 2a plus the c over 2b, quantity squared, plus negative a over 2c, quantity squared, just like that. And we'll square everything, so we'll get b squared over 4a squared plus c squared over 4b squared plus negative a times negative a squared will become positive a squared over 4c squared. And now you'll notice that we have 4's in the denominator. We can actually factor out the fraction 1/4, and we'll get b squared over a squared plus c squared over b squared plus a squared over c squared. And if you remember from prior videos, those squared ratios worked out to be positive 5. So we're going to get 1/4 times positive 5. So we're going to get 5 over 4. So therefore, the sum of the cosines squared of pi over 7, 2 pi over 7, and 4 pi over 7 will add up to 5 over 4. And one of the interesting things about this is this calculation actually popped up in the calculation of sine of pi over 7 times sine of 2 pi over 7 times sine of 4 pi over 7 equaling root 7 over 8. I didn't realize that until after I had done the calculation, and I always found that interesting. Okay, we're going to move on to the next problem set here in a second. Now our next problem is we're going to do sine squared of pi over 7 plus sine squared of 2 pi over 7 plus sine squared of 4 pi over 7. And we're not going to do anything real drastic with this. We're actually just going to appeal to the Pythagorean identity of sine squared alpha plus cosine squared alpha equals 1. And what will happen is we'll just take 1 minus the cosine squared of alpha to get sine squared of alpha, just like that. So quickly, I'll just put these in parentheses. 1 minus cosine squared pi over 7 plus 1 minus cosine squared of 2 pi over 7 plus 1 minus cosine squared of 4 pi over 7. And this works out quite neatly. We have, we can distribute the pluses through, get rid of the parentheses. We have 1 plus 1 plus 1, which is 3. And then we take away, notice how we have the negatives on each of the cosine squared ratios. We can factor that out, and we can get cosine squared of pi over 7 plus cosine squared of 2 pi over 7 plus cosine squared of 4 pi over 7. And what we get is 3 minus 5 over 4, because 5 over 4 is what we got in the last problem. We can write this as 3 over 1. Well, I'm not going to show that, but 3 times 4 is 12. 5 times 1 is 5. So we'll get 12 over 4. Actually, I am going to show it. Minus 5 over 4. And that's going to get us 7 over 4. So the sum of the sines squared of all the angles in the heptagonal triangle work out to be 7 over 4. And really, 7 showing up here and the 5 showing up here really aren't that surprising because in the last video we had the square root of 7 showing up. So what we'll do now is it will lead into the last problem that I want to cover in this video. All right, everyone, and in the last part here, we're going to take the sine squareds that are being added together, and we're going to do a little bit of analysis with them. Now, let's go back and remember what the sine ratios were for pi over 7, 2 pi over 7, and 4 pi over 7. If you remember, they worked out to be a over 2r, b over 2r, and c over 2r. We had to bring in the circumradii to get a nice set of variable ratios in order to get what we need for all those different sines. Now what we're going to do is we're going to take each of these sine squared ratios and we're going to replace them with their variable ratios. So a over 2r quantity squared plus b over 2r quantity squared plus c over 2r quantity squared. And what did these equal again? Well, down below you notice that it's 7 over 4. So we're just going to write down 7 over 4 here. Now let's work these out. We'll get a squared plus 4r squared, b squared plus 4r squared, plus c squared over 4r squared equals 7 over 4. Now what will happen is because of this, we can actually factor a whole, we can cancel the 4's on both sides here, and then we can multiply everything by r squared. And we're going to get the nice a squared plus b squared plus c squared equals 7 times r squared. And this is a nice variable expression where we have the lengths of the three sides being squared and they'll add up to 7 times the circumradius squared. So we have a nice relation of the sides and the circumradii or the circumradius put together, and that'll lead into all other sorts of calculations, both trigonometric and not especially trigonometric, that can be derived from it. It's quite an interesting trip that I intend to take you on over the next several videos. All right, I hope you enjoyed this one. I enjoyed making it. This is Geek37 signing off.